Okay, so week 2, set 1, this is the notes for SWYK 2. You'll notice in this particular graphing situation, I have taken the first one and solved it for y, and by doing that, so I added the 2x. Now you'll also notice that I divided by -1, and whenever we divide by -1, oh, whoa, mistake. Should say y is less than or equal to -2x minus 2. Yep. Man, I messed up there. Good thing I caught it in the video. All right, so less than or equal to, because when you're dividing by a negative number, sign switches. Okay? The other two are as simple as they can get, right? This one is a horizontal line. In fact, it's a solid horizontal line, and it's going to be shaded above. This one is, believe it or not, a vertical line. It is a solid vertical line. Anything that's x equals is always a vertical line, and greater than for a vertical line would be shaded to the right. Less than would obviously be shaded to the left. This one's going to be a solid line. So let's go over here and take a look at our picture. And yes, we've got the red one, and we said it is, obviously we said I made a mistake on that. That should be less than or equal to. And if it's less than or equal to, that's going to be solid line going like this. And of course it's shading below. And then we've got the green one, the vertical line, right? Or no, the horizontal line. Sorry, the next one would be the horizontal line. And it's going like that. And it is greater than, so it's shading above. And then, of course, we've got the last one, which is the blue one, which is the vertical line. Oops, that is not the right tool. So, blue one, shaded to the right, and better get my red one back. And that's shaded down. And so where do they all overlap? They all overlap inside here. There's your shaded region for this one. There's all this stuff inside here. Anyway, that's how you do that particular example. Okay, let's go to the next one. So a couple things here I wanted to highlight for you or remind you of. The absolute value function, the blue one I did there, an absolute value function gives you basically a V shape that bounces off the origin. And if you multiply it by -1 in front of it, or any negative number, you cause it to flip over. Of course, being -1, it just looks almost the same, it's just upside down. Okay, and also wanted to remind you of a couple things that maybe you talked about in Algebra 1, but haven't thought about in a while. If you do a change on the inside, it's going to look backwards. So if you say x minus 3, lots of kids want to say, oh, that goes left 3. Well, in order to make up for the loss of 3 units, you need to pick bigger x's, which forces it to the right. So what happens when you go x plus? Well, that does force it to go to the left. You'll see that the green one I did also had the negative in front of it, so it got flipped over. So I just did a couple examples there of absolute value functions so you can see those particular things. Okay, for this particular example, we have a horizontal line. It's a dotted line, and it's got to be shaded up. Okay, so we know that much. Dotted line shaded up. Then we've got a V shape that is that opens up, but it's been shifted to the left one. Left one. It's a dotted boundary V, and it opens up, but it's shaded below because we want y as less than. Okay, so let's take a look at putting all those pieces together. Oops, wrong thing. Well, we can obviously get rid of choice A and B because they have solid V boundaries, so that means those are out. I mean, those solid V boundaries don't make any sense to me. You'll notice that in C and D, both of the V shapes, the absolute values, are shaded, are drawn correctly. They both meet left one and they open up. The difference is that one is shaded above. You can see in the picture here that one gets shaded above the V and one gets shaded below the V. So which one do we want? Let me go back up here and look. We do want below the V because, of course, we've got that whole less than or equal, less than. So we want below the V. That immediately gets me my choice, the correct answer here, which would be this one. And of course, the other one you can see the dotted boundary line shaded up. So you get these two sections that are separated from each other. And yes, they go on forever and ever and ever, here and here. That kind of stuff. Kind of infinite triangular shapes. Okay, question 3 here. We have another situation. We've got a horizontal line. It's a dotted line, and it's shaded above because of the greater than. Then we have this one being moved right to. It is opening down, right, because of the -1 in front. And it's a solid boundary, and it's shaded below. So we got to put all these pieces together and, see what we have for choices here. First of all, horizontal line, and it has to be shaded above. Okay, so A is a possibility. The horizontal line is shaded above. B is not, because the horizontal line is shaded below. So that's a bad choice. D, let me see, D, that is a solid line. We needed a dotted line, so that's a bad choice. So this one's a dotted line, even though I drew a solid line for some strange, stupid reason. I don't know. And it is shaded above, so that's good news. So now we got to decide between these two. So we're moving right to, oh, ding, 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 we just found it. The V went to the right 2 units. Okay, this one went left 2 units, so that got rid of that choice. So we can easily kind of rule out the bad choices just by looking at individual pieces of information. Okay, that's enough for SWYK number 2.